High-altitude balloons are large, helium-filled balloons that carry scientific payloads and experiments up into the Earth's atmosphere and closer to the edge of space. Before flight, all NASA TechRise experiments will be hooked up to the balloon's power and data, mounted to a frame called a gondola, and launched into the sky. If it's after sunrise, not raining, and cloud cover is less than 30%, then we are a go for launch. Once the balloon and gondola start ascending into the sky, the experiments can start using their onboard sensors and cameras to collect data. The experiments will have exposure to the air around them, views down to Earth's surface, and views out to the horizon. The higher the balloon goes, the colder it gets. And since air pressure decreases with altitude, the balloon will expand from big to huge. It will also travel through different layers of the atmosphere. It'll take about 30 to 45 minutes to ascend through the troposphere, which is the layer we live in, and the layer that has almost all of our planet's weather, like clouds and water vapor, which are constantly moving. About 75% of the air from our atmosphere is in the troposphere, and it's by far the wettest layer. Next is the stratosphere, which is above the clouds and where the winds are calm and dry. This is where commercial airplanes typically fly and where you'll find the ozone layer. Ozone molecules in the atmosphere absorb a lot of the sun's harmful UV radiation and in the process generate heat. Unlike the troposphere, it actually gets warmer the higher up you go in the stratosphere. During flight, the balloon's altitude can be adjusted by venting helium to go lower or dropping weight to go higher until it reaches its target float altitude of 70,000 feet, where NASA TechRise experiments will float for at least 4 hours. Experiments can also use the balloon's vehicle telemetry. The balloon's onboard flight computer will send messages to the experiments, including GPS data of where it is, altitude data of how high it is, or acceleration data of how fast it's changing speed. You can program a microcontroller to use this data to start or stop your experiment at a certain altitude, or to map where you took a particular photo, or to log how far your experiment traveled. And once the mission is complete, the experiment will be shut off from power before the gondola separates from the balloon and parachutes back down to Earth. A crew will try to retrieve it and send your experiment home.